Many of us enjoy brain teasers and puzzles as recreational activity. I, for one, really enjoy doing Sudokus and crossword puzzles while I'm on airplanes, and I like to do jigsaw puzzles. All you're really doing in these simple tasks is figuring out the correct organization or order of something, or you're trying to, solve a problem or an answer. With relative dating, you're kind of doing both. You're trying to figure out what came first and what happened for a given chunk of strata or a given block of geologic layerings. So your approach when you're going through your relative dating problems can be from top to bottom, bottom to top, can based off of your preferences, but for me the easiest way to do it is by starting at the bottom and seeing what is bottommost and is that likely to be the oldest. And then you would pencil in. If you're printing out and working on the hard copies, I definitely recommend pencils versus pens because I make mistakes on these all the time. It's very likely that you will too, especially if it's your first go of things. So you'll start looking for the bottommost layers because the bottommost are likely to be the oldest. Likely but not guaranteed, because you'll also look for intrusions. As you know from our Principles of Stratigraphy video, if something is intruding on other layers, it's going to be younger than the layers it's intruding. So you look for intrusions, you look for inclusions, you look for cross-cuts. Here we have a dike cross-cutting these horizontal layers. You look for unconformities. That's what this bolded squiggly line is here and the bolded squiggly line up here is. You look for faulting activities. You can list the fault line. If it says fault 1 or 2, fault A or B, you would list those in your layers of oldest versus youngest. So looking at this one here, you would see that the one that's indicated as A, being the bottommost, will be the oldest. Next oldest is B, and then following B, you would look and see, well, this intrusion J here has also been eroded alongside the B layer relative to that unconformity, that angled unconformity we see right there. That has also eroded down layer J. So J came around after A and B, but was pre-existing before the unconformity event happened. So it goes A, B, J, unconformity, C, D, E, F, and you see G up here. And then we have another unconformity, we have a dike, and we have displacement. So now looking at the fault, we can tell that the fault happened before the dike intruded because the dike is not broken or displaced by that faulting. The faulting relative to the unconformity is not super clear, but if we look at the dike, we see that the dike is also cut off by the unconformity. So whatever happened after G is most likely to have been the faulting, then the intrusional dike, the cross-cutting, then the unconformity. Now moving up to the youngest two layers, we would have H and lastly I. So working through and paying attention to all intrusions, inclusions, displacements, original horizontality being shifted onto its side and perhaps tilting, 70, 80 degrees, you'll have to look and see which one was most likely on the bottom, what folding probably happened here, and did the faulting happen before or after. On one of your examples, you're going to have 2 faults and 2 dikes, and you're going to have to reference back and forth to determine which one happened first. It might take you a few goes, it might be a little bit frustrating, but hopefully you'll find it fun too after you get the hang of it.